Okay, I decided to make a part 2. Hopefully there can be a part 3. Uh, yeah, I'm sorry about the inconvenience. Okay, anyways, again, looking for the distance is looking for the area. And the distance traveled from time 10 to 20 is basically looking for the area of region B. So what is the area of B? The length is, say, 15. The width is 20 minus 10, which is 10. So the area is 150 meters. Well, yeah, you have to write the units. Speed is meter per second. Time is 10 seconds. So you cancel the S's, you remain with the meter unit. So, so distance traveled from time 20 to 30 seconds. Uh, the rate, well, let's just remove this. It's a wrong solution. Uh, so it's these guys. I'll just keep that last question for now. Uh, so at 20 to 30 seconds, you have to solve for the area of a trapezoid. There's another way of solving this, but you require two formulas. Um, divide the shape into two pieces. One is a triangle, one is a rectangle. And yeah, just. But for uniformity, I prefer to use the trapezoid formula. It's a lot more convenient in my opinion. Uh, okay, so area of a trapezoid, base 1. So wait, the height is this one. This is the base 1, this is the base 2. So what's the height? 10, 30 minus 20. And then times base 1 is 50. I forgot to write the units. 10 seconds. And then we have 15 meter per second plus base 2, that is 25 meter per second, and then divided by 2. We have 30, 40. 40 times 10 is 400. Uh, cancel the unit second, so we have meters left. 400 divided by 2 is 200 meters. Distance traveled from 30 to 50 seconds. We have a triangle, a massive one. The base is going to be 20, and the height is going to be 25. So area of what shape is this triangle is equal to base times height over 2. The base is 20, the height is 25, 20 seconds. And then since the y-axis represents the number of, basically the time in hours, and the height is the speed in meter per second, which is 25. 20 times 25 meter per second, we have 20 times 25, 500 meters divided by 2, 250 meters. Zero to 50. Hmm. I believe the distance traveled throughout the entire journey from 0 to 50 seconds, you just find the sum of all of the areas. Kindly disregard that information, the one I just erased, and yeah, just find the sum. So let's start with 250 and then 200 and 150. What's the last one? 75. So 400, 600, 675 meters. Let's check if I got the answer correct. Well, yes. Uh, but I just hope that I write this in the exam. Although yes, my solution and my answer is correct, but I can be marked for incomplete solution. Uh, yeah, the way I should write everything into solution is kind of exaggerated, but yeah, it's very important for you to make sure you don't miss out on any um, part that's very crucial. One common mistake is with the unit. So yeah, even write down the units. So let's move on to the next worksheet. Uh, we have 5 kinematic formulas. Uh, we've already discussed 2 of them. So velocity is distance over time. If there's a final and initial, uh, follow the pattern final minus initial on both the numerator and denominator. For acceleration, we have Vf minus Vi over the time total. Uh, this is the part officially of the kinematics formula, but speed is equal to the total distance over the total time. So yes, it's important to know the differences. Velocity, df minus di, tf minus ti. For speed, distance over time total, as you can see, for acceleration, the denominators, together with the formula for speed, are the same. And for velocity, uh, the numerator for velocity is the same as the numerator for acceleration. It may be confusing, but yeah, it's up to you to find a way to memorize these formulas, find their differences, find the stark differences. Computing for the average velocity is very simple. Add the sum of the velocities, final and initial, and divide it by 2. And we have 2 formulas for distance.